friends, welcome to the another session. In today's session, we'll be discussing about the basic concepts of parabola. So, what exactly the parabola? So, before getting into parabola, we need to know a quick recap of conic section. So, if there is a fixed point and a fixed line, so this is a fixed line and this is a fixed point. So this fixed point is called focus and fixed line is called the directrix. And a variable point P is there which is moving that the ratio of the distance of the point from the fixed point to the fixed line. This SP by PM is constant. Then we call it as this one as the conic. The locus is called the conic. E is called the eccentricity. F is called the focus. And this line is called the directrix. So if E is equal to 1, this is the parabola. E is less than 1, it's an ellipse. E is greater than 1, hyperbola. Okay. So E is equal to 1 ellipse. E is less than 1 ellipse. E is equal to 1 parabola. E is less than 1 ellipse. E is greater than 1 hyperbola. Okay. So now a general equation of the conic. What is the general equation? That is the second degree equation. Ax square plus 2hxy plus by square plus 2gf plus 2gx plus 2fy plus c is equal to 0. This is the general second degree equation. And what is the delta of this equation is this. The general second degree equation also we use in the pair of lines. So here delta is equal to 0. It will be pair of lines, different categories. For conic, delta should not be equal to 0. So delta is not equal to 0. H square is equal to AB parabola. Delta is not equal to 0. H square less than AB ellipse. Delta is not equal to 0. H square greater than AB hyperbola. And it's a special case. Delta is not equal to 0. H square is greater than AB. And A plus B is equal to 0. A plus B is equal to 0 means this is going to be actually in the pair of lines it will be perpendicular. So that is called rectangular hyperbola whose eccentricity is root 2. And S is equal to 0 represent the conic. Center is this one. HF minus BG by AB minus H square. GH minus AF by AB minus. This is by using partial differentiator. Dou S by dou X is equal to 0. You take this equation. And dou S by dou Y partially differentiate with respect to it. You solve these two, you are going to get this one. Okay. So if AB is equal to H square, for parabola H square is equal to AB. So that means denominator goes to 0. For parabola there is no center. For parabola there is no center. Okay. Look at this diagram. There are the various things. This is the directrix. This is the vertex. This is the perpendicular line through the focus perpendicular to the axis. This is called the lattice rectum. Any line perpendicular to the axis is called the double ordinate. And any line through the focus is called focal chord. Any line through the focus is called focal chord. So what is the quick recap? What is the axis of conic? Conic is, axis of the conic is the line which is perpendicular to the directrix and passes through the focus of the axis. So same thing can be right in the other way. Line of symmetry. Line of symmetry. Line of symmetry is also called as the axis of the conic. Vertices. Vertices means here one vertex is possible or two are possible. So the points of intersection of the conic and its axis are called the vertices of the conic. Focal chord. Any chord of the conic through the focus is called focal chord. Double ordinate. A chord of the conic perpendicular to the axis. Lattice rectum. The focal chord of the conic perpendicular to its axis is called lattice rectum. A focal chord means a focal chord of a conic perpendicular to axis. Okay, so focal chord means it's a lattice rectum has to be focal chord and perpendicular to the axis. Or you can say a double ordinate passes through the focus. Double ordinate through the focus is called lattice rectum, or focal chord perpendicular to the axis is also called the lattice rectum. Focal distance. The distance from focus to any point on a conic is called focal distance. Okay, so focal distance means if this is the conic, here focus is there. Now this point has to be on the curve. This is called focal distance. You cannot take this point and this is focal distance. No, you cannot call this one as a focal distance. You can call this one as a focal distance. Or on this curve is going, this is also called the focal distance. The point has to be on the curve and the distance of that particular point from the focus is called focal distance. Okay, now coming to these are the things are common for ellipse, all the conics. Now I'm moving into the ellipse. The definition of the parabola. So for whatever these definitions are common for ellipse, hyperbola, parabola. Now I'll go to the parabola. What is the definition of parabola? Eccentricity is 1. So SP by PM is equal to 1. What is the mean? SP should be equal to PM. What is the mean? P is a point equidistant from fixed point and the fixed line. Parabola is a focus of a point moves such that its distance from fixed point is always equal to its distance from fixed straight line. That is the definition of the parabola. SP by PM is equal to 1. SP by PM is equal to 1. So, what are the standard parabolas we have? The parabolas we have y square is equal to 4ax. This parabola will be like this. Y square is equal to minus 4ax. This parabola will be like this. X square is equal to 4ay. This parabola is like this. X square is equal minus 4ay. This parabola is going to be like this. So, of those things, let us look at here. Okay. So, y square is equal to 4x. So, the figure is missing in this one. Let me draw. And this is the vertex, x-axis and y-axis, because vertex is 0, 0. And here it is. And this is. y square is equal to 4ax, y square is equal to minus 4ax, x square is equal to 4ay, x square is equal to minus 4a. Vertex is 0 comma this one. Focus is a comma 0 minus a comma 0, 0 comma a and minus a comma 0. Here a comma 0 minus a comma 0, 0 comma a, 0 comma minus a. Directrix x is equal to minus a, x is equal to plus a, y is equal to minus a, y is equal to plus a. Equation of lattice vector. This is x is equal to a, x is equal to minus a, y is equal to a, y is equal to minus a. Okay, so these are the main four parabolas, but we'll call it as this one as the standard parabola, and all the formulas derived about this one only. Okay, the diagrams also come. Let me clear. Yes. Okay. Now, for all those things, what is the tangent at the vertex? Tangent at the vertex for this one. For this one also, tangent at the vertex is this. For this one, tangent at the vertex is x-axis. This is tangent at the vertex. Equation of the axis. This is the equation of the axis. Axis. This is the axis and this is the axis. Length of lattice rectum is simple. Y square is equal to 4ax. Whether plus or minus, this is the lattice rectum. 4a, 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 4a. End of lattice vector means if this point is a comma 0, this is a comma 2a, a comma minus 2a. This is a comma 2a, a comma minus 2a. If these are the lattice vector, minus a comma minus 2a, this is minus a comma 2a, minus a comma minus 2a. This 2a comma a minus 2a comma a. This 2a comma minus a, this is minus 2a comma minus a. So focal distance of any point you can take it as y square is equal to 4x. Okay, abscissa plus length of lattice rectum, and parametric point is this, but you concentrate on this one only. Parametric point as at square comma 2at. We call it as generally this point t. We call it as point t. Origin is the vertex. 4a is length of lattice rectum for all these parabolas. Okay, that's over the previous case. Now you look at here. These are the two special parabolas where axis vertex is not at the origin. You have these coordinate axis. Okay, so somewhere here you have h comma k. This is a parabola. So this is y minus k is equal to length of lattice rectum, a units if I take 4a into x minus h. Similarly, h comma k, this one, this point is h comma k, focus is a units. This is x minus h whole square is equal to 4a into y minus k. So all the measurements accordingly directrix will come here, tangent at the lattice rectum will come here, and everything changes accordingly. And another important point is if parabola axis is parallel to x-axis. If axis is parallel to x-axis, the parabola is going to be in the form of x is equal to ay square plus by plus c. If axis is parallel to y-axis, the parabola is going to be y is equal to ax square plus bx plus c. So from here A, B, C, three unknowns are there. To derive the parabola, we generally require three conditions. Okay, same thing as given here. There is nothing. Now, notations and uh, standard points here. S is equal to y square minus 4ax is equal to 0 parabola. S1 replace here y square and 4x. So what I'll do is I will write y1 minus 2a into x plus x1. S1 is. And for example, S11 will be equal to y1 square minus 4ax. So if this is a parabola, s is equal to 0, any point here we call it as inside parabola. Any point here we call it as outside of the parabola. How we derive this one is if S11 greater than 0 outside, S11 is equal to 0 on the parabola, S11 less than 0 inside the parabola. Okay, next, if this is x1, y1 and x2, y2, chord joining x1 and x2, you can write it as s1 plus s2 is equal to s12. This is the chord joining x1, y1, x2, y2. See, this is holds good for parabola, ellipse, hyperbola. Even for circle also the same condition. Chord joining two points on curve S is equal to 0. Curve S is means S can be circle, S can be parabola, S can be ellipse, S can be hyperbola. Depending on the situation, whatever. But chord joining two points on the curve x1, y1 and x2, y2. S1 plus S2 is equal to S12. Okay. Now, what is the condition for tangency? So, what is happening here? If this is the curve, this is a line x11. What is s1 is equal to 0? S1 is equal to 0 represents the tangent. Represents the tangent. So y square is equal to 4ax is the curve. Because it's you are going to write the m set, every point is important. Because you don't have time there to derive. These are the four standard things. If the tangent is of the form y is equal to mx plus c, condition for tangent is c is equal to a by m. And if this is the point, c is equal minus a by m. If x square is equal to 4ay, c is equal minus am square. X square is equal minus 4ay, c is equal to am square. And at this time, what is the point of contact? A by m square comma 2a by m minus a by m square comma minus 2a by m. And this is, oh, minus 2am comma minus am square. So here what will happen? This point is 2am comma am square. Sometime. Okay. Next one is, if Lx plus My plus n is equal to 0, tangent of this particular form, Am square is equal to Ln minus Am square is equal to Ln, Al square is equal to Mn minus Al square is equal to Mn. During that time, these are not ones beta, you take it as L. So in this case, what is the point of contact? What I suggest you to remember basically is, for this condition and for this condition, you remember. Remaining is not that important, but try to remember. If any question comes on that one, should be in a position to write. But under any circumstances, you should not miss out on these two. Okay. Next one. If theta is angle between, so from external point I can draw pair of tangents. From external point I can draw pair of tangents. So what is this pair of tangents equation is, S1 square is equal to S into S11. This is the equation of pair of tangents. Please understand, this is holds good for circle, parabola, ellipse, hyperbola. For all the four curves, S1 square is equal to S into S11 will be pair of tangents. Now, what is the angle between the pair of tangents? Tan theta is equal to root S11 by x1 plus a. Root S11 by x1 plus a is the angle between pair of tangents. If this angle is 90 degrees, this point is going to be lies on the directrix. Okay, so the locus of point of intersection of perpendicular tangents to a parabola is directrix. Now, if this point is meeting at T1 and at T2, okay, so what is this point? The point of intersection of tangent at T1 and T2. This point will be A T1 T2 A into T1 plus T2. Now, joining these two, what we call chord of contact. Chord of contact. If this point is x1, y1, this chord of contact is s1 is equal to 0. Okay. So just have a look at this. Please read these properties. Tangent drawn at the, see again. Now, if this chord is passes through focus, we call it as focal chord. If this is the focal chord, T1, T2 is equal minus 1, and the tangents will be perpendicular. I'll explain that one in the next one. Let me write here. See, if this is a parabola, like this point is T1, this point is T2, tangents were drawn. For example, if the focus, it is passing through the focus, then T1, T2 is equal minus 1. Slope of this line is minus 1 by T1, slope of this line is minus 1 by T2. At that time, this point will be equal to, okay, A T1, T2 minus A comma something. So, which is a point on directrix, point on directrix. So, what is the tangent equation I told you? S1 is equal to 0. So, what is the y square is equal to 4x. X minus yt plus x plus yt plus, okay, at square is equal to 0. Okay, this tangent equation is, sorry, tangent is x minus yt plus at square is equal to 0. Slope is equal to 1 by t, 1 by t. So, if this is the point on the directrix, this angle 90 degrees. Or if this is the focal chord, this is 90 degrees. So pair of tangent from the directrix always, okay, chord of contact of point on the directrix is a focal chord. A tangent drawn at the end points of the focal chord always intersects on the directrix perpendicularly. So these points are very important. You have to read more effectively, carefully. If SPQ is a focal chord, okay, focal chord, what is the mean? Like this. Your S is there, your P is there, your Q is there. 1 by SP plus 1 by SQ is equal to 2 by 2A. Actually, why I'm writing is these are in HP. This is semi-lattice rectum. Length of lattice rectum is 4A. This is semi-lattice rectum. So 1 by SP plus 1 by SQ is equal to 1 by A. I write 1 by SP plus 1 by SQ is equal to 2 by 2A. Length of the focal chord y square is equal to 4x, making an angle. So if this line is making an angle of theta, this PQ will be equal to 4a cosecant square theta. 4a cosecant square theta. A circle drawn on the focal chord as the end points of diameter. So what happened? Because this is the focal chord, the tangents are going to be perpendicular and intersects on the directrix. So angle in semicircle will be right angle, right? So the circle drawn on the focal chord of parabola as diameter touches the directrix. Okay. The circle drawn on focal radius means if you take this part, this, so this is the focal radius, touches the tangent at the vertex. Okay, if you take this one as the end points, it is going to touch the tangent at the vertex. Equation of the normal at x1, y1 is this one, but we need to remember this one. Y is equal to mx, okay, minus 2am minus am cube. So m is the cubic equation. So if you take the parabola, if some x1, y1 is here, I can draw three normals passes through this point. This is a m1, here m2 will be there, normal, so perpendicular to tangent, and this is m3. Okay, so we can talk about the properties of that. Now y is equal to mx plus is the normal to the parabola. This is the condition. Condition for yx plus lx plus my plus n is equal normal to this one. Okay, al square plus 2alm. So I'll not suggest you to remember this one. What I suggest is, if some line is given, whether it is a normal or not, what I'll do is the general form of the normal equation. Here it has given. What is that one? Y plus xt is equal to atq plus y plus xt is equal to atq plus 2at. Whenever someone is asking lx plus my is equal to n is the normal, I suggest you to go for the simplification instead of remembering this one. Okay. And on this slide, what are the points? Other points to be remembered is, if the normal at T1 point, if the normal at T1 meets the parabola again at T2, then T2 is equal to minus T1 minus 2 by T1. This is what you need to remember. And if three normals are drawn through a point, so this is one normal, this is one normal, this is one normal, then sum of their abscissa should be equal to 0. Okay. So because you look at here, when you take this one as a cubic equation, here what happened? AM cube. So sigma m is equal to 0. Sigma m is AM square m. So sum of the ordinates must be 0. So these three are called, okay, put up the perpendiculars of the things corresponding point. So the centroid of these three triangles always lies on the axis of the parabola. If the normal at T1 meets the parabola again, so look at normal at T1, normal at T2. Both are intersecting on the parabola again. T1, this point coming. Somewhere here T2 is there. This is also coming in here. So during that time, then what is T1, T2 is equal to 2. And if this point is T3, so T3 is equal to minus T1 minus T2. Okay. So, and one more thing, you can write it as T3 is equal to minus T minus 2 by T, we will write T1. And similarly, T3 is equal to minus T2 minus 2 by T. Okay. With the help of this one, you can write T1, T2 is equal to 2. Centroid of the triangle formed by the feet of three normals of parabola lies on the axis of parabola. Already we discussed. Slope of the tangent and normal at any point t is 1 by t and minus t respectively. Normal at t on the parabola subtends right angle at its focus, then t is equal plus or minus 2 at its vertex is plus or minus root 2. Okay. To any parabola, three normals can be drawn from any point on its axis which distance is greater than or equal to 2a. P is a point on parabola, focus S, tangent normals meet this. So what is this one? Look at here. Point is there, tangent is meeting at T, normal is meeting at N. Okay, this is 2 and here it is S is the focus. So what will happen? No? This length is equal to this length is equal to this. All these three lengths are equal. All these three lengths are equal. And any ray traveling parallel to the axis and hitting the parabola, it will pass through the focus. This is a reflection property. Okay. So with this one, I'm concluding the session. But with the problems, we'll discuss few more shortcuts and few more properties which are required. Thank you very much.